right, we are continuing our notes from 1.3 for stats, and we are on to our last page of notes here about standard deviation. Okay, so standard deviation is another way to say it is the average spread from the mean. So the average spread from the mean, that means in its formula, guess what? It's going to have mean in its actual formula. Okay, so what is the actual formula for standard deviation? So first of all, the symbol for it is S sub x equals, okay, it's just standard deviation, okay, S sub x. And then there's a few steps to it, but it's basically we're going to take every point, so x sub 1 is the first point, we're going to subtract it from x bar, that's the mean, and we're going to square it. I said that backwards. We're going to subtract the mean from the point and then square it, and then we're going to keep doing that. From each individual data point, we're going to subtract the mean from it and square it. And we're going to do that forever. And then we're going to divide that whole amount by n minus 1. Remember, n is just the number of numbers in the list. And then we're going to take the square root of the whole thing to get to standard deviation. Isn't that fun? Okay. On a formula sheet that you're given for the actual exam, it says this. It says S sub x equals, and it says under a square root, it has 1 over n minus 1. Can you see that that is the same thing so far? Oops, let me move that down a little bit. It is the same thing so far as what we had over here, right? We've got this part right here covered, okay? And then the next part is it's going to do the sum of x sub 1 minus x bar squared. So they're basically saying add them all up, right? So sum means add, so it says add them all up. So that second part takes care of all of this up here and the square root. Okay, you can see how those all work into that other formula. All right, so let's go and do one. Let's talk about what you actually have to do for these, and let's go do one. All right, so how do we actually do one? Do we have a formula on here somewhere? What is going on with this thing? Where did it go? It went off the screen. How weird is that? Okay, hang on. I don't know why it went off the screen, but I will put it back. All right, so let's go and find one. So step number 1 is you need the mean, right? You got to find the mean, okay? Step number 2, you're going to have to find the distance from each point to the mean, and then you're going to square it. So I'm going to say square each from number 2, from step number 2. Okay, and then the next thing is we're going to add up all the number 3's. So we're going to add up all those squared numbers. Okay, and then number 5, we're going to divide it all by n minus 1. And then 6, we're going to take the square root of number 5, of step number 5. That is the way you get to standard deviation. It's got 6 big steps to it. Okay, so we're going to go and calculate the standard deviation for this one right here. Okay, so I'm just going to start off right away of doing each one of these numbers. So I know that the mean is, let's see if we can find it, and then the how many are in the list. So I have 10, 20, 30. 30 divided by 6. So 30 divided by 6, we have a mean of 5. All right, so let's go and start working on putting those into the formula. So I'm doing 1 minus 5 squared plus 1 minus 5 squared plus 5 minus 5 squared plus 5 minus 5 squared plus 8 minus 5 squared plus 10 minus 5 squared. Okay, and then I'm going to do that all over n minus 1 is 6 minus 1, and I'm going to put them all under a square root. Okay, so that is S sub x equals. All right, let's go calculate these. So if I calculate these, I'm going to get 4 squared is 16, right? 1 minus 5 is negative 4, but it's really just distance squared, because when we square it, even if it's negative, it's going to turn positive. So I'm going to start out with 16 plus 16, and then 5 minus 5 are zeros. So plus 0 plus 0. Okay, so I've done this one, this one, this one, and this one. Okay, then the next one is 3 squared, that's plus 9. And then we have the last one was 10 minus 5. 10 minus 5 is 25. Okay, and that's all going to go over 5, and we're going to square root it. All right, so now I'm going to have to go calculate that, and I've already previously calculated this. This is 66 over 5, which is 13.2. And if I put a square root over that, the square root of that would be about 3.633. So square root, standard deviation is 3.633. Okay, so what does that mean? Well, it means that all of my data points on average are about 3.633 away from the mean of 5. Most of my points is just giving me a picture that 5's the middle, and most of them vary away from it by about 3.6. Okay, so most of them vary away from it. There's also another word in here that got cut off that we're going to put back on, and that is the word variance. And it showed up here. I'm going to rewrite it. So variance equals standard deviation squared. So if you take off that square root, you have variance. Okay, so the difference between variance and square root is if you square if you square the standard deviation, you get variance. If they give you variance, you want to get to standard deviation, you take the square root. Okay, they're distances, right? So they're both going to be positive numbers. Okay. All right, so next one it says how to choose between mean or median and IQR or standard deviation. Okay. Wait, I want to write this down so that you actually have a word for this. So I would say this standard deviation of 3.633 is the typical distance of the values from the mean. Now, if it's in a word problem, you would replace some of these with words, and you would say, you know, 3.633 feet is the typical distance from the average height of 6 feet, or something like that. Okay, so you'd put in the context of the problem. All right, so how do we know whether to display data using mean and median or IQR and standard deviation, right? Because we now know how to calculate all of these. It's so many formulas, right? All right, so let's talk about these. So you are going to use median. Okay, think about this. Median, what was it resistant to, right? It was resistant to outliers. So you're going to use medians if the distribution is skewed in either direction. You're going to use median if there are outliers. You're going to use median if it is multimodal, like you look at it and it looks like it might have more than just one central area. You are going to use median if it looks weird in any way, shape, or form, basically. Okay, so anything that doesn't look pretty. Now we'll talk about what pretty is. So what goes along with median? When we're using median, what was our measure of some kind of spread or an average amount away from the middle? That would have been IQR. So IQR goes with this one. Anytime you talk about median, you should be talking about something that goes with median from the 5-number summary, so IQR. Okay, on the other side, we have mean and standard deviation. Standard deviation, that's horrible, standard deviation. Okay, so when do we use mean and standard deviation? Well, here we're going to use this when it's symmetric, when the graph looks symmetric, like foldable. Okay, and no outliers. Okay, so mean and standard deviation go together. So notice that in order to use mean, there's a very limited number of ways that you would use mean. It's just if it looks symmetric and pretty and no outliers. The second it looks weird in any way, shape, or form, you're going back to 5-number summary to talk about it. Don't keep using mean and standard deviation unless they specifically ask you. It's human nature to want to say average, so we tend to lean towards the blue side. We need to realize that anytime the distribution looks weird, we're going towards the pink side of median and IQR. Okay, so let's talk again about resistant or not resistant. Standard deviation, well, that's going to move just as much as mean does, so standard deviation is not resistant. It is not resistant. It's going to move. It's not going to stay stuck. Variance, well, variance goes with standard deviation, so it is not resistant. Okay, so we did 2 no's. Okay, what about mean? Well, mean goes with that side as well. We already did that with a huge outlier. It is not resistant. Okay, median, however, is resistant. IQR, resistant. Range, resistant. Get the idea here? Everything on one side is resistant, everything on the other side is not resistant. Okay? All right, let's see what else we've got going on. There might be one of those that doesn't quite work that way. Let's see. Oh, yeah. What about range? If I add in an outlier, that's going to way change my range. So this one, even if it's in the 5-number summary, is going to be not resistant. It's not going to stay put, right? If I add in a humongous number, it's going to move. Okay? Again, calculator stuff, we'll go over that when we come back, but it's there if we need it. And then this part starts out with be careful. Okay, be careful of looking only at a number table and not plotting the data. So a number table is like this, where it says there were 5 people with 10, there are 4 people with 3, something like that. Be very careful about number tables without plotting the data. What you really should be doing is saying 5, there's 10 points above it, right? Or doing a bar graph or something, and that 4, there's 3, right? It's very difficult to show multiple peaks and stuff like that without actually going back to the actual numbers, okay? All right, and that is it for 1.3. So we'll do some practice on this in class. Thank you guys for hanging out. We'll see you later.